Hello everybody, I'm back, sorry for the delay. As I think I said in the last one, I was away doing exams. I have come back and this job has appeared on my bench. This is a light fitting. It does not fit on my bench properly. I've even had to switch the lens on the camera out to a wider angle one so you can see the edge of the bench here, and it still doesn't all fit in the picture. But this is a, hopefully you can read it, this is a Robus fitting, which is strange because usually they're fairly high quality and this one has died, but it's died in an interesting way. It's a Robus product code is RDA 1530-30, 220-240 volt for 60 Hz. It is a 15 watt, 3000 Kelvin color temperature. Basically it's an over mirror light which mounts on the top of a cabinet or above mirror for lighting up in a bathroom. IP44, as you can see, for the bathroom, double insulated, which is an important bit I will get into in a second. As you can see, we have only two contacts in here, line neutral because it is double insulated. I've stuck a bit of flex on here, and there is a little earth wire that we have added here. I will explain what that's for in a second as well. Now, this has failed in an interesting manner. I will show you some video of it in situ in the bathroom it was removed from, which is actually my bathroom, which is why I'm fixing this rather than just replacing it, because these are technically still available to buy. Anyway, this light fixture, for some reason, when you turn it on, nothing happens until you touch the metal end cap, and then it'll work fine. Which is very, very weird. My guess is that it's probably for some reason the switch mod driver in this doesn't start, and when you touch the end cap you're providing a earth path for a very tiny amount of current to leak, and that's allowing it to start, which is bizarre. Anyway, as a test of that, we added this earth wire, just shoved it in here and attach the other end of it to the earth metal cabinet this was on top of, and it worked perfectly fine. You turn it on, it'll turn on, and it did that for a couple of weeks and then has now stopped and is intermittent. So I thought we should have a look and see if we can work out what the hell's going on. Now I'm going to have to see if I can produce a hoppy, which I can. And I will put the, see if I can get this all to fit. We will put the wires here into the speaker terminal of the hoppy. They're a bit long there, but there we go. That'll do. Move the hoppy there so you can see the numbers. It is currently drawing no current, nothing at all. Then let's see what happens when I touch the end of this. Nothing. That might be because I'm on the second floor of building here, so I don't have a very good earth. So if I earth myself with my ESD earth. Oh, there we go, see, that worked. And it is drawing 15 watts, power factor of 0.6, 0. Or 100 milliamps. Yeah. This is what I mean about it being very strong. I don't know if you can see there, all I was doing was just tapping my finger onto the end of the light fitting. Bizarre failure mode, I've never seen this before. Oh, just turn that off. Ah, and now it works. Okay, I'm just going to give this a second here to discharge. I'm going to get my multimeter in and we'll measure the earth leakage when you touch that and see how much current leaks. One moment. Okay, so here we go. I have my multimeter here. One end of that is attached by a croc clip to the ESD earth on my bench. I have it set to microamps, and I'm going to touch the other probe of the meter. There we go. Going to touch the other probe of the meter. Ah, see, that was me just touching it to move it there, and has triggered it. Okay, I'm going to need to turn this off again, let it discharge, and we'll try and measure it this time. Okay, take two. So, meter probe, I'm just going to touch to the end of this. There is no current. I don't know if you can read. This meter does not have a backlit display, which is not amazing, but... Oh, that's, I've got it set to DC, and stupid me. There we go, AC leakage. 8.4 microamp. Okay, we'll try it to the back. Nothing. 8.4 microamp. Try it on the other end. 8.4 microamp. This earth wire here, again 8.4 microamp, is just attached onto the end. But for some reason that's not starting when I do that. I'm going to try now, I will touch the end of this, and then I will touch that and see if that starts it. 9 microamp of leakage, but still doesn't work. If I let go of that, that goes away. See if I take my feet off the floor, makes no difference. Okay, this is behaving very strangely, because I would have assumed when I touched the earth directly to it, it should work. You just saw it start when I touched it. I wonder what happens if I take the earth directly and touch the end of it. Nothing. This is a right puzzler, because now it seemingly doesn't do anything when I touch it. Right, let's try and get this taken apart, because I don't know what else to try with testing here. So we'll get it taken apart and have a look and see what there is on the inside. I'm guessing a switch mod driver, but who knows, might be wrong. So I have extracted from the inside, this is the aluminium extrusion that they're using as a heatsink. You can see on the top of the board here we have, well, a board which has all the LEDs on it. These are in series, I can see by the traces just the whole way down the board, all series with the incoming plus and minus. Inside the end of this, I'm pretty sure there's some sort of driver unit. I can't see exactly what it is yet, so I'm going to try and get that out, but I will just show you this. I think I am probably going to have to try and get this out the bottom in order to see if I can slide everything out the end, but we'll see. Okay, so back to a more normal format now. This is the offending driver, and as I was saying, with Robus products being of very high quality, I don't know if you'll be able to make it out, but they have double heat shrinked over the top of this driver. There is 2 layers. I can get a screwdriver there and show you. There's a finer one. There we go, that'll do. Yeah, there are 2 layers of heat shrink here, like that, which the... there we go. See, there are 2 layers of heat shrink. So, let's cut the heat shrink off. We'll see what is underneath. Because these are all in series, the LEDs, this is not going to be probably a buck regulator. Well, it might be, but it's probably not going to be a standard low voltage supply. It will be a constant current driver, I bet. Might be using one of those bright power chips, but they're usually for light bulbs, which are not so big. 15 watt is quite a lot of power to be forcing through. So there we go, 1 layer of heat shrink off. We then have another one underneath. So I have reverse engineered the module. I have split it into two parts, so this schematic here is up to that point on the board, and then this point on the board is another schematic I have here. I'll go over this quickly. We have the incoming supply here on these tails, which is those two there. There is a 5 ohm fusible resistor, which is that bit here. The switch is on these wires at the end. And then we have a common mode suppression choke, which is here. There is then a small interference capacitor here, a differential mode suppression choke, I think it is, which is this with a resistor on the other side across the back of it. We have the full bridge rectifier here. Coming out on the other side, we have a metal oxide varistor and a primary smoothing capacitor, which is these two here. As I said before, Robus products always very well designed, and this is no exception. This is just interference suppression, which is amazing. That's why you pay the money for them, is because it's so well designed. Now, the important part is the actual switch mode driver itself, which is all based around this chip here. This chip says on it BP2861. I have looked up a datasheet for a chip with a... It is BP2861, and then it has something else up on the end of it, which usually that just is, like for example, when you have a 555, it might say NE, NF, there's various different sort of things you stick on the end, which just tell you slight variations about the chip, like is it low power, designed for switching high current, blah blah blah. I was assuming it's that. I don't think it is, because this schematic bears no resemblance at all to the schematic in the datasheet, and the pinout on the datasheet is completely different to the pinout here. I did cover up a slight mistake I made there with these resistors, but that is not important. Anyway, we have a 20k resistor between pins 1 and 2. Pin 3 is not connected to anything. Pin 4 is the incoming VCC to power the chip. Then we have these two resistors here, 2.7 and 2.2 ohm resistor in parallel for the current sense. The pin 7 is actually missing on this chip here, it's not even there, so obviously not connected either. And then pins 5 and 6 here are connected together, which go into the inductor. There is a capacitor network here, which is those two capacitors there. Not marked with anything, and I'm not going to take them off to measure the value, but they are, I assume, interference suppression again. We then have on the other side another small capacitor, a load resistor of 150k, and a 56 microfarad smoothing capacitor, which is this big one here. That then comes out on their side to here and here, which is the LEDs themselves. The positive of that, or sorry, the negative of that goes back to common earth, and the positive one is coming out the end of this inductor. The LEDs are all in series as well. Now, in terms of this actually fixing it, I am not even going to attempt to. I was kind of hoping that there would be some sort of external startup circuitry that I could probe with and see what was going on. There isn't. It's probably internal to the chip, and if it is internal to the chip, then yeah, it's not going to be fixable, I'm assuming. So I'm just going to stick this to the side. In terms of how to resurrect the light, move these schematics out of the way. The actual LED board itself, I'm pretty sure still works. I will test in a minute, but I'm pretty sure it should still work. I could make my own driver for this. I could do it with like capacitive dropper, probably that would work. I'm trying to think what else I could do. You could do a resistive one, but that would be very, very inefficient. I don't have another switching driver to use for it. What could do is, because these tracks are very easy, you could cut the tracks and rearrange this into smaller sections. Sorry, we could cut the tracks, say cut the track here, then you have 3 in series, cut the track here, and you have another 3 in series, cut the track here, and you'd have another 3 in series. Make all those parallel and just use this like a bit of LED tape, say 12 volt, 24 volt, 5 volt, whatever. Could do that, that's another option. Or if we get the aluminium extrusion, we could just stick some more LED tape on the top of the aluminium extrusion here and see if I can fit another driver into the hole in the end there. I'm going to have a think about this and see what I've got lying around that I can use to make a driver or adapt to something, or yeah, I'll come up with something. I'll have to have a think about it one moment. So I had a think about how to fix this, and what I've done, because I don't think I'm going to be able to repair the driver board, I could have taken another driver board out of like an LED bulb or something. I just wired that in as a direct replacement, but it probably wouldn't have fitted inside the end of the tube. So I decided to make this into low voltage DC. What I've done is I've gone, for every 3 LEDs, I've cut the trace and added a resistor, 100 ohm resistor in line with each of the sets of 3. I've connected the positives down as a common bus bar with this somewhat messy wire here, and I just have the positive and negative going inside the tube and coming out in the junction box at the back. So if I get my bench power supply and I set it to 12 volts, say 300 milliamps current limit for starts, it shouldn't, yeah, it should be less than that. So we attach those like that, turn this on, and we have life. All of them look to be working. Yeah, I fixed it. That was easy. They do seem to be... Yes, I made a bit of a mistake there. I was realising this setup here looked awfully bright. That will be because I forgot to put a resistor for the 3 here. So I will fix that. Yeah, I'll fix that. 1 second. So there we go, I have now put it back together again. You can see when I turn it on, the diffuser looks good. I had to play with the wiring a little bit inside to make it so it wasn't casting shadows on the top of the diffuser. But yeah, I have resurrected this. I'm just going to stick probably a standard 12 volt lighting driver somewhere inside the cabinet or inside the wall or behind it, or I'll figure something out. Anyway, I have resurrected this. Very interesting. I say very well designed, as usual with Robus products. I would have gone back to them with warranty on this, but this is like 4 years old, I think, so out with its warranty. But I would be interested to know if this is a common failure mode on them, or if there's something else going on. I think it must be something to do with the startup circuitry, obviously, and it is probably some sort of capacitive issue, with it capacitively coupling to the metalwork of the fitting, I think. But honestly, I have no idea. I'd be interested on input from other people about if they'd seen anything like this before. I've spoken with a few other electricians around the place, and none of them have ever heard of anything like it happening with anything else, so yeah, an unusual one, but interesting as usual. I'll turn this off so I'm not blinding you all. Anyway, thank you very much for watching. Hopefully you enjoyed it. Please stick in the comments if you have any ideas of what could be causing this. I'm stumped, to be honest. I'm not really sure. Never seen anything like it. But as I say, thank you very much for watching. I will see you in the next one. Goodbye.